Welcome to the session Refractive Index of Prism. The aim of this experiment is to determine the refractive index of the material of the prism by ID curve method. The refractive index of any medium is defined according to Snell's law, the ratio between the sine of angle of incidence and the sine of angle of refraction. Refractive index of a given medium is represented and mu is equal to sin I by sin R. In this experiment, we are going to determine the refractive index of the material of the given prism using ID curve. Here, I is the angle of incidence and D is the angle of deviation. Angle of incidence is the angle subtended between the normal drawn to the one of the refracting surfaces of the prism and the incident ray. Angle of deviation is the angle subtended between the incident ray and the emergent ray. The apparatus we are going to use in this experiment is drawing board, drawing paper, prism, geometry box, and drawing pins. The formula we are using in this experiment for finding the refractive index of the material of the prism, mu is equal to sin A plus dm by 2 by sin A by 2. Here, capital A is the refracting angle of the prism. Dm is angle of minimum deviation. Now, in the given prism, the angle of deviation D is equal to I plus E minus A. I is angle of incidence, E is angle of emergence, and A is angle of prism. Now, in the minimum deviation condition, I is equal to E. Then capital Dm is equal to I plus I minus A, which is equal to 2I minus A, given by I is equal to A plus Dm by 2. And if R1 and R2 are the angle of refractions at the two refracting surfaces, then angle of prism A is equal to R1 plus R2 in the minimum deviation position of the prism. R1 is equal to R2. Then 2R is equal to A and R is equal to A by 2. Using Snell's law, mu equal to sin I by sin R. Substituting the values of I and R, we get mu is equal to sin A plus dm by 2 by sin A by 2. In this, angle of minimum deviation is determined by plotting ID curve. The angle of prism capital A will be given. It is equal to 60 degrees if it is equilateral prism. In this experiment, we are going to determine the angle of deviation for different angles of incidence. Consider the drawing board. Place the drawing paper on the board and fix the paper with the help of drawing pins at the four corners of the drawing paper. Consider the given prism at the center of the drawing paper and trace the sides of the prism with the help of a pencil. Name the three faces. AB and AC are refracting faces and BC is the base of the prism. Consider a point N on the face AB and draw a normal MN with the help of a protractor for the face AB. Now, draw a 30-degree line from the normal with the help of the protractor. P and Q are 2 points on this line. PQ is the incident ray and angle of incidence is 30 degrees. Now place the prism and consider 2 ball pins. Fix them at points P and Q so that the 2 pins must be on the same straight line. We have to observe the 2 pins from the second refracting surface AC in such a way that the pin that is going to be placed on the other side must coincide with the images of P and Q. Consider one more pin, let us say capital R, and we have to observe the pins P and Q from refracting surface AC in such a way that the pin R must coincide with P and Q. Observe that P, Q and R are on the same line. Consider one more pin, let us say S, and observe the pins P and Q from refracting surface AC such that pins of P and Q and R should be on the same line with S. We say the images of P and Q and the pins R and S are on the same line when we observe from the refracting surface AC. This line which joins R and S is the emergent ray from the face AC. Now remove the prism, remove the pins and join R and S with the help of a scale to meet the refracting surface AC at V. And now extend the line PQ to T in the forward direction. And Vs in the backward direction. Consider O as the meeting point. The angle subtended between T, O, S is angle of deviation D. And the angle between MN and PQ is angle of incidence. We took here, it is equal to 30 degrees. By using a protractor, we can measure the angle of deviation. Here, for 30 degrees angle of incidence, the angle of deviation here is 50 degrees. Repeat the same procedure for angles of incidence 35 degrees, 40 degrees, 45 degrees and 50 degrees. We have to determine their corresponding angles of deviations. The observations are: for angle of incidence 30 degrees, angle of deviation is 50 degrees. For 35 degrees angle of incidence, angle of deviation is 46 degrees. For 40 degrees angle of incidence, angle of deviation is 40 degrees. For 45 degrees angle of incidence, angle of deviation is 44 degrees. For 50 degrees angle of incidence, angle of deviation is 48 degrees. we observe that with the increase in the angle of incidence up to 40 degrees, the angle of deviation is decreasing. It is decreasing from 50 degrees to 40 degrees and then it starts increasing. We identify the angle of minimum deviation from this graph as 40 degrees. Therefore, dm is 40 degrees. Now substituting the value of dm 40 degrees and capital A 60 degrees in the formula mu equal to sin A plus dm by 2 by sin A by 2. Mu is equal to sin 60 plus 40 by 2 by sin 60 by 2. That is sin 50 by sin 30. Then mu is equal to 2 sin 50 degrees. Therefore, mu equal to 1.532. Therefore, the refractive index of the material of the prism is 1.532. Precautions. Pins should be fixed vertically and there should be no parallax error. Pins should not be disturbed after they are fixed. Care should be taken while going to consider the collinearity of the images, and finally the same prism must be used for different observations. Conclusion. Thus we conclude this experiment, refractive index of prism, after finding the refractive index of the material of the given prism as 1.532.